So welcome, this is CAIE, Major in 2010, paper 33, pure maths 3, question 33. So there are something around 10 questions, but the 10th question is from the concept vectors and planes. It is deleted and it is been sent to for the pure mathematics. So therefore we are doing only the 9 questions. The first question is from inequality. So first squaring on both sides, x minus 3 whole square is greater than 4 times x plus 1 whole square. So x square minus 6x plus 9 is greater than 4 times x square plus 2x plus 1. So it becomes x square minus 6x plus 9 is greater than 4x square plus 8x plus 4. Bring all the terms on one side, we get 3x square plus 14x minus 5 is less than 0, because 4x square minus 3x square is 3x square. Negative 6x goes to the other side, it becomes positive 6x. 8x plus 6x is 14x, and 4 minus 9 is going to be minus 5. Now factorize this one. I'm directly writing the answer. It should be 3x minus 1 times x plus 5 is less than 0. 3x minus 1 times x plus 5. Check that whether it does make sense. Yes, it should be making sense. So x lies between negative 5 and positive 1 upon 3. That's going to be the answer for the question number 1. Coming to question number 2, the variables x and y satisfy the equation y is equal to y cube is equal to ae to the power of 2x. The graph of ln y against x is a straight line. Find the gradient of this one. So I apply ln on both sides. Ln y cube is equal to ln ae to the power of 2x. 3 ln y is equal to ln a plus ln e to the power of 2x. So 3 ln y is equal to ln a plus 2x ln e. Ln e is 1. So from there I get 3 ln y is equal to 2x plus ln a. Compare the equation y is equal to mx plus c. We can make that the slope is going to be m, but we have 3, so therefore divide by 3 on both sides. So I get it out. Ln y is equal to 2 upon 3x plus ln a upon 3. Now comparing it out, the gradient is going to be 2 upon 3. The gradient is 2 upon 3. Given that the line intersects the axis of ln y at a point ln y equal to 0.5, find the value of a in two places of decimal. So ln y is equal to 0.5. He has given ln y is equal to 0.5, find the value of a. So 0.5 is equal to 2 upon 3. It intersects the axis of ln y. So axis of ln y means x value has to be equal to 0 plus ln a upon 3. So ln a is equal to 3 times 0.5, a equal to e to the power of 3 times 0.5. So do by calculator. It should be getting it out. Shift e to the power of 1.5. 3.0.5 is 1.5. In 3 significant figures, 4.48. That's going to be the answer. Question number 3. Tan 45 minus x is equal to 2 tan x, giving all solutions in the interval of 0 to 80. Tan a minus b formula. What is tan a minus b formula? We need to remember tan a minus b formula is tan a minus tan b upon 1 plus tan a tan b. So tan 45 minus tan x upon 1 plus tan 45 tan x is equal to 2 tan x. Tan 45 is 1. So 1 minus tan x upon 1 plus tan x is equal to 2 tan x. Do the cross multiplication. 1 minus tan x is equal to 2 tan x times 1 plus tan x. So 1 minus tan x is equal to 2 tan x minus plus 2 tan square x. Now bring all the terms on one side, you get a quadratic equation. 2 tan square x plus 3 tan x minus 1 is equal to 0. So this is a quadratic. A is equal to 2, B is equal to 3, C equal to negative 1. So tan x is equal to minus B plus or minus square root of B square minus 4AC upon 2A. So it becomes minus 3 plus or minus square root of 9 plus 8 upon 4. So that becomes negative 3 plus or minus square root of 17 upon 4. Take both the values. First value is negative 3 plus square root of 17 upon 4, and another value is negative 3 negative root 17 upon 4. Do tan inverse of that one. Tan inverse of negative 3 plus square root 17 upon 4. Do by the calculator. Keep the mode of the calculator in degrees. So tan inverse negative 3 plus square root 17 upon 4. This should be giving you 15.7. And another angle x is equal to tan inverse negative 3 negative root 17 upon 4. Go back and change the values as negative 17 upon 4. This should be giving you 119.3 degrees. So these are the two answers. Question number 4. Given that x is equal to 1 when t equal to 0, solve the differential equation. So dx upon dt equals to 1 upon x minus x upon 4. So dx upon dt equals to 4 minus x square upon 4x. Make a common denominator on the left hand side. Then this was dt. Bring the x terms on this side. So 4x upon 4 minus x square dx is equal to dt. Then apply integral on both sides. Now what it should be doing, 4x can be written as 2 times 2x upon 4 minus x square dx is equal to integral of dt. Why am I doing like that? Derivative of denominator should be present in numerator. Denominator is 4 minus x square. Its derivative is minus 2x. So therefore I am multiplying with minus and minus. It becomes plus only. The reason is we have a concept that if I have a function in the denominator and its derivative is present in the numerator, then the answer is ln or integral will be ln denominator or log denominator. Doesn't matter. So what is that? A denominator should have a function. Its derivative should be present in the numerator. So over here the denominator is 4 minus x square. Its derivative is minus 2x. It should be present. So therefore I introduced a minus in the numerator. So what does that becomes now? Negative 2 ln 4 minus x square is equal to t plus c. Integral of dt is t plus c. Has he given any value? X equal to 1, t equal to 0. He given x equal to 1, t equal to 0. So minus 2 ln 4 minus 1 is equal to 0 plus c. C is equal to minus 2 ln 3. And what is he asking? Find x square in terms of t. So I got negative 2 ln 4 minus x square is equal to t minus 2 ln 3. So t is equal to 2 ln 3 minus 2 ln 4 minus x square. So now t equal to 2 common, ln 3 upon 4 minus x square. So ln 3 upon 4 minus x square is equal to t upon 2. 3 upon 4 minus x square is equal to e power t upon 2. So I want x square as a subject, so do the reciprocal, it becomes e power minus t upon 2. So 4 minus x square is equal to 3 e power minus t upon 2. X square is equal to 4 minus e power 3 e power negative t upon 2. That's going to be the answer. Anything else has been asked? That's it. Question number 5. The diagram shows the curve y is equal to e to the power of minus x, e to the power of minus 2x and its maximum point m. The x coordinate of m is denoted by p. Find the exact value of p. So first we have to find dy by dx. dy by dx, e to the power of minus x derivative is minus e to the power of minus x plus 2 e to the power of minus 2x. E to the power of minus 2x derivative is minus. Minus times minus is plus, and 2x is 2. So I got the derivative. Now this derivative should be equal to 0. So minus e to the power of minus x plus 2 e to the power of minus 2x is equal to 0. So I have to get the value of x. So what am I going to do? 2 e to the power of minus 2x is equal to e to the power of minus x. So minus e to the power of minus x has been taken to the other side. So e to the power of minus 2x upon e to the power of minus x is equal to 1 upon 2. So e to the power of minus x is equal to 1 upon 2 minus e to the power of minus x. So I apply ln on both sides or ln on both sides. Ln e to the power of minus x is equal to ln 1 upon 2 can be written 2 power minus 1. Why am I doing that? Minus ln x ln e is equal to minus ln 2. So that minus minus and can be cancelled. So x is equal to ln 2 because ln e value is 1. That is the x coordinate of the maximum point. Now coming to the second part, show that the area of this shaded region between the bounded by the curve, the x-axis and the line x is equal to p is equal to 1 upon 8. So I have to find the integral from 0 to ln 2 for the curve. What is the curve equation? E to the power of minus x minus e to the power of minus 2x. E to the power of minus x minus e to the power of minus 2x dx. E to the power of negative x integral is minus e to the power of negative x minus e to the power of negative 2x integral is minus e to the power of negative 2x or e to the power of negative 2x divided by minus 2 from the limits 0 to ln 2. So it is minus e to the power of negative x plus 1 upon 2 e to the power of minus 2x from 0 to ln 2. Substitute the upper limit, minus e to the power of minus ln 2 plus 1 upon 2 e to the power of minus 2 ln 2. Then minus, substitute lower limit, minus e to the power of 0 plus 1 upon 2 e to the power of 0. Now simplify that. So minus e to the power of ln 2 power minus 1. That minus you can bring it up to the power 2 power minus 1 plus 1 upon 2 e to the power of ln 2 power minus 2 minus e to the power of 0 is 1 and again e to the power of 0 is 1. Now we know a property that e to the power of ln 2 means e and ln gets cancels, e and ln gets cancels. So I get minus 2 to the power of minus 1 plus 1 upon 2, 2 power minus 2, minus times minus is plus 1 minus 1 upon 2. So it becomes minus 1 upon 2 plus 1 upon 8 plus 1 minus 1 upon 2 is 1 upon 2. 1 upon 2, 1 upon 2 gets cancels. What's going to be the answer? 1 upon 8. That is going to be the answer required to be proved. Coming to question number 6. Y is equal to ln x upon x plus 1 has one stationary point. Show that the x coordinate of this stationary point satisfies this equation and it lies between 3 and 4. So first what do I have to do? I have to find dy by dx. So x plus 1 whole square, x plus 1 ln x derivative is 1 upon x minus ln x derivative is 1. So this should be equal to 0. So x plus 1 upon x minus ln x upon x plus 1 whole square. So do the cross multiplication, x plus 1 upon x minus ln x is equal to 0. So x plus 1 upon x is equal to ln x. So x plus 1 upon ln x is equal to x. I think so that only has been asked us to prove. And we have to prove that this lies between 3 and 4. So bring all the terms on one side, x minus of x plus 1 upon ln x. This will be f of x. Let it be equal to 0. So what am I going to do? find f of 3. So it is 3 minus 3 plus 1 is 4 upon ln 3. Take the calculator. 3 minus 4 upon ln 3. This value is negative 0.65. Negative 0.641. Then I find f of 4. 4 minus 4 plus 1 is nothing but what? 5. 5 ln 3. So 4 minus 5 ln 3. So 4 minus 5 divided by ln 3. So it becomes instead of ln 3, it should be ln 4 because we are substituting x is equal to 4 ln 4. So go back and change the values to ln 4. So it should be equal to positive 0.39. We can see that they are opposite signs. So what am I going to write it out? As f of 3 and f of 4 are having opposite signs. Opposite signs. Root lies between 3 and 4. Now to the next part. Use this iterative formula. What was that iterative formula? Xn plus 1 is equal to xn plus 1 upon ln xn. And we know that it lies between 3 and 5. So we will take the initial value as 3.5. So let us take the initial value in 3 and 0.5. N is equal to 0. So x0 plus 1 is equal to x1 is equal to x0 plus 1 upon ln x0, which is 3.5 plus 1 upon ln 3.5. It should be giving me 3.5921. Then I take n is equal to 1. x1 plus 1 is equal to x2 is equal to x1 plus 1 upon ln x1, which is 3.5921 plus 1 upon ln 3.5921. So I go back and change the values. So it becomes 3.5911. So I stop over here itself only. Luckily at 2 iterations you can see that it's 2 decimal places is 3.59, 2 decimal places is 3.59. So therefore the answer is, the root is 3.59. Coming to question number 7. Prove that the identity cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. Cos 3 theta is equal to cos 2 theta plus theta, cos A plus B, cos A cos B minus sin A sin B. We can see that everything is in terms of cos. So cos 2 theta is 2 cos square theta minus 1 times cos theta. Sin 2 theta is 2 sin theta cos theta times sin theta. So it becomes 2 cos cube theta minus cos theta minus 2 sin square theta cos theta. So it becomes 2 cos cube theta minus cos theta minus 2 cos theta times sin square theta is 1 minus cos square theta. So it becomes 2 cos cube theta minus cos theta minus 2 cos theta plus 2 cos cube theta. So 2 cos cube theta, 2 cos cube theta add up, it becomes 4 cos cube theta minus 3 cos theta. That's going to be the answer. Using this result, find the exact value of this integral from pi by 3 to pi by 2. From pi upon 3 to pi upon 2. So we got that cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. So what am I going to do it on? I am going to apply integral on both sides. So I want to make cos cube theta as a subject. So 4 cos cube theta integral will be equal to d theta. It will be equal to integral of cos 3 theta d theta plus 3 integral of cos theta d theta. We can apply the limits. So I write 4 integral of cos cube theta d theta is equal to cos 3 theta integral. Cos 3 theta integral is nothing but what? Sin 3 theta upon 3. Don't forget to write upon 3. Then 3 cos theta integral is sin theta. We know the limits are from pi by 3 to pi by 2. So don't forget to substitute the limits pi by 3 to pi by 2. Pi upon 3 to pi upon 2. Now substitute the limits. So it should be 4 integral of pi by 3 to pi by 2 cos cube theta d theta should be equal to 1 upon 3 sin 3 pi by 2. Upper limit I am substituting plus 3 sin pi by 2 minus 1 upon 3 sin 3 pi by 3 plus 3 sin pi by 3. So 3 pi by 2 is minus 1 plus sin pi by 2 is 1, then minus 1 upon 3 sin pi is 0, sin 3 pi by 3 is root 3 upon 2. So this becomes negative 1 upon 3 plus 3 minus 0 minus 3 root 3 by 2. So it becomes 8 upon 3 minus 3 root 3 upon 2. This is for 4. Remember it was 4 cos cube theta d theta. But I want for only for cos cube theta d theta. So integral of cos cube theta d theta, bring that divide by 4. So 1 upon 4 times 8 by 3 minus 3 root 3 by 2. So it becomes 2 upon 3 minus 3 root 3 by 8. That's going to be the answer. Coming to question number 8, I have directly done this on a few calculations to save the time. It says that the equation 2x cubed minus x squared plus 2x plus 12 is equal to 0 has one real root and two complex roots. Show your working, verify that 1 plus I root 3 is one of the complex root. So for verifying 1 plus I root 3 as one of the complex root, just plug in wherever x is there 1 plus I root 3 and do the simplification and you should be able to get 0. Once you get 0, it is going to be the root. That is the easiest way. If one of the root is 1 plus I root 3, so other root is 1 minus I root 3. Now find the other complex root. So other complex root is nothing but what? 1 minus I root 3. On a sketch of an Argand diagram, show that the point of intersection, a point representing the complex number 1 plus I root 3. On the same diagram, shade the regions whose points represent the complex number z minus 1 minus I root 3 is less than or equal to 1 and argument of z is less than or equal to pi by 3. So we have to take an Argand diagram. So x-axis and y-axis, x-axis is going to be my real axis and y-axis is going to be my imaginary axis. 1 plus I root 3, so this value of x is 1 and root 3 is maybe 1.732. This is a point and the origin is O. What is he being told over here? Modulus of z minus 1 minus I root 3 is less than or equal to 1. What does this integrate? It integrates represents a circle with center 1 comma root 3 and radius 1. It represents a circle with center 1 comma root 3 and radius is 1. This distance is 1 and radius is 1. So this distance is 1, but because it is root 3, so it should not touch the x-axis, whereas it should touch the y-axis because the distance is going to be 1. It should not touch the x-axis, but it should touch the y-axis. So this is going to be a circle, but that is not looking like a center. So therefore, what am I going to do? I am going to change the value over here. This may be the center 1. Okay, that is the center. Now it is inside the circle. Now what is the point? Now what is being asked? and also argument of z is less than or equal to pi by 3. Pi by 3. Argument of z means angle. If it is passing through the center, it's going to be pi by 3. So it is less than or equal to pi by 3. So what's going to be my shaded region? Shaded region should be inside the circle and less than pi by 3. This is going to be the answer. Last question, express into a partial fractions. 4 plus 5x minus x square upon 1 minus 2x times 2 plus x whole square. So it is a upon 1 minus 2x plus b upon 2 plus x plus c upon 2 plus x whole square. So 4 plus 5x minus x square is equal to a times 2 plus x whole square plus b times 1 more 2 plus x and 1 minus 2x plus c times 1 minus 2x. Now plug in x is equal to negative 2. So 4 minus 10 minus 4 is equal to a times 0, b times 0 and c times 5. So it becomes negative 10 is equal to 5c, c is equal to negative 2. Then plug in x is equal to 1 upon 2. So 4 plus 5 upon 2 minus 1 upon 4 is equal to a times 2 plus 1 upon 2 whole square and b times 0 and c times 0. So this is 16 plus 10 minus 1 upon 4 is equal to a times 5 upon 2 whole square, 25 upon 4. 4 gets cancels. This is 26, 25. 25 is equal to 25a. So this gives me a is equal to 1. Now I got a value, b value, c value. So I want to get it out b value. So comparing the coefficients of x square. On left hand side x square is 1. On right hand side it is a and x times negative 2. So negative 2b gives you coefficient of x square. Negative 1 is equal to 1 minus 2b. So 2b is equal to 2, which gives me b value as 1. So what are the fractions now? 1 upon 1 minus 2x and b value is 1 upon 2 plus x and c value is negative 2 upon 2 plus x whole square. What is asking in the next form? Hence obtain the equation of this expansion of this one in ascending powers, including the terms of x square. So we have to expand all the three. So I take first 1 upon 1 minus 2x. So it is 1 minus 2x whole to the power of negative 1. So 1 plus nx. Then n minus 1 upon 2 factorial x square. So it becomes 1 plus 2x. Then this you simplify it out, 2 gets cancels, minus gets cancelled, so it becomes 4x square and so on. Take the second one now, 1 upon 2 plus x. So 1 upon 2 common, 1 plus x upon 2. So 1 upon 2 times 1 plus x upon 2 whole to the power of minus 1. So 1 upon 2 times 1 plus nx, then n minus 1 upon 2 factorial x square. So it becomes 1 upon 2, 1 minus x upon 2 plus x square upon 4. So it becomes 1 upon 2 minus x upon 4 plus x square upon 8. Now the last one is minus 2 upon 2 plus x whole square minus 2 upon 2 plus x whole square. So minus 2 upon 2 common, 1 plus x upon 2 whole square. So it becomes minus 2 upon 4 times 1 plus x upon 2 whole square. So it becomes minus 1 upon 2, 1 plus x upon 2 whole to the power of minus 2. So minus 1 upon 2, 1 plus nx plus n minus 1 upon 2 factorial x square. So it becomes minus 1 upon 2, 1 minus x, 2 gets cancels, plus 3x square upon 4. Then simplify it further, minus 1 upon 2 plus x upon 2 minus 3x square upon 8. So now we got 3 fractions. Add all the 3 fractions. So copied on the first one from the first. The answer for the first one. Then the second one. And finally the third one. So I'm adding the first plus the second plus the third. So you can see that 1 upon 2, 1 upon 2 gets cancels. 1 upon 2, 1 upon 2 gets cancelled, so I'm left over with 1. Then I have to take the values of x. This is 2x minus x upon 4, x upon 2. So 2x minus x upon 4 plus x upon 2. So common denominator is 4, 8x minus x plus 2x. So it becomes 9x upon 4. So 1 plus 9x upon 4. Now coming to the x squared terms. X squared terms, I take it as 4x square upon 8 minus 3x square upon 2. So it is 4x square plus x square upon 8 minus 3x square upon 8. So common denominator is 8. 32x square plus x square minus 3x square. 33x square minus 3x square, 30x square upon 8. So my final answer is going to be 1 plus 9x upon 4. Cancel with 2, 15x square upon 4. That's going to be the final answer. So that completes the paper. See you in the next paper. Bye.